slide. Lecture 1, which I don't have here. Perfect. Pause all recording. There we go. Okay. Things to know from lecture 1. Things to know from lecture 1. Make sure you know all of these functions. Okay? All 5 of these functions. Muscles produce body movement, they stabilize body positions, control body openings and passages, they generate heat, so they're involved in thermoregulation, and they're involved in glycemic control. Remember that muscles contain a lot of glucose or glycogen, that's sugar, that they can release when it's needed. Know these 4 properties of muscle. Muscles do one thing, they contract, contractility. Muscles are extensible, that means that they can get longer. And elasticity is the muscle's ability to bounce back to its original shape. Excitability just means that they're excitable through nervous tissue, right? We talked about motor neurons and how they generate action potentials to allow muscles to contract. So know those 4 properties. I would just know that myoblasts are immature muscles and myocytes are mature muscles. Myocytes are actually multinucleated because they fuse. The myoblasts fuse together. Other things here. What I would know for this is those coverings that are outside of the muscle. So the one that's around the muscle itself is called a what? Epimysium. The one in the middle is the perimysium, and then around each of the fascicles is the endomysium. So know those coverings. I've just highlighted those kind of here for you. So muscles have an epimysium. Fascicles are connected by a perimysium, and within the fascicle you have these fibers, which are surrounded by endomysium. That leads to myofibrils. Those myofibrils, again, are just those actin and myosin filaments that interact. Know the 3 functions of fascia. 3 functions of fascia. It's very simple. Fascia serves as an origin for skeletal muscles. Fascia allows groups of muscles working together to operate more smoothly to reduce friction. And the last major thing about fascia is that it's a transit area for blood vessels and nerves. And so you can see that here. All these blood vessels and nerves are transiting through the fascia. Where do we find fascia in the body? Well, lots of different places. Fascia is made up of dense, regular CT, connective tissue. And so you can imagine like fascia itself is like a tendon that you might hammer down and flatten into a sheet. So that's what fascia really is. So it's very strong. Where do we find fascia? Well, the thoracolumbar fascia we find in the back. The cranial aponeurosis we find on the top. It's also called the glia aponeurotica. And then we find it on the palm. So the palmar aponeurosis. We find it on the foot, the plantar aponeurosis. Those are the major places that we find large amounts of fascia. Muscles can attach to bones in different ways. If they attach with a tendon, well, that's an indirect attachment. Indirect attachment. The muscles of your face are different. They are a direct attachment. No tendons are involved. Muscles have different shapes. You'll get a multiple choice question about the shapes of muscles. If we think about shapes of muscles, you have rhomboids. You have kind of triangular or fan-shaped muscles. You have muscles that are round. Those, if you see teres is round, teres is a shape. Wink, wink, teres is a shape. So I'll ask you about those shapes of muscles. And then you know that pennate means feather-shaped muscle. There's unipennate, bipennate, and multipennate. Know that the deltoid is an example of a multipennate muscle, which means it has 3 separate tendons. The deltoid is an example of a multipennate muscle. Know that there's a difference between fusiform and non-fusiform muscles. Fusiform just means it has a belly to it. examples of fusiform muscles are the biceps brachii, which is both fusiform and parallel. A muscle like the sartorius is non-fusiform. It's flat, it's straight, it does not have a belly. Even though the rectus abdominis is on your belly, it doesn't have a belly itself. It is actually parallel fibers, and so it is non-fusiform. Okay. And then you're going to get a section on levers and fulcrums, and I'm going to explain this later when we're in the review. I'm going to tell you the exact examples that you need. Okay. And then everything here is just different ways to name muscles, and so a lot of this we already know at this point. So nothing else, everything that in this latter part is kind of embedded in the things that you know. That's it from the first lecture. Okay. Any questions about that? Slow twitch fibers and fast twitch fibers. Slow twitch fibers, what makes muscles red? Myoglobin. So what has more myoglobin in it? Fast twitch or slow twitch muscles? Slow twitch muscles. Slow twitch muscles, do they use glucose as a fuel source or do they need oxygen?
Oxygen.
They need oxygen. So slow twitch muscles, if you need oxygen, we say that they are aerobic muscles. Fast twitch muscles you find in the muscles around your eye or your fingers. They look white because they lack myoglobin, and they are glycolytic. That means that they use glucose or sugar as a fuel source, and so they do not need oxygen. So they are anaerobic muscles. So just remember those. If a muscle gets bigger, that is atrophy or hypertrophy? Hypertrophy, and if it gets smaller because it's not being used, that's atrophy. Alright, so a lot of this we've already kind of covered, so I'm going to skip over I'm going to go faster over a few things. Okay. Now, you're going to get a couple of questions on how muscles act as levers, and this is going to be in the multiple choice, in the matching section of the exam. Basically, there's three types of levers. There's a first class lever. First class. In a first class lever, what you have is the fulcrum in the middle. You have a load on one side, and then you have a force being applied to help move that load. An example of this, so it kind of looks like a seesaw. The only example of this to note is here with the splenius capitis and the atlanto-occipital joint. Really, it's the occipital condyles and atlas. That articulation is a pivot joint. It kind of acts like a seesaw. So that is an example of a first-class lever. What determines that is just where the position of this fulcrum. In a second and third class lever, the fulcrum is at the end. The fulcrum is at the end. And then the difference here is that either the force is being applied from the middle and lifting the load, or the load is in the middle and the force is being applied at the end. I always switch these to just my brain, but this is a second class lever. And this is a third class. All you need to know is an example of each of these. So an example of a second class lever is going to be how your calves pull on the calcaneal bone so that you can stand on your tiptoes. Here, your tiptoes are the fulcrum. The movement of the load is in the middle. That's the calcaneal bone. And the force that's being applied is coming from the calf. So standing on your tiptoes is an example of a second class lever. The last one here is in third class lever. We only see this really in one place. And that is when you have, again, the fulcrum is at the end, But what's different is like the force is being applied from the middle and the load is at the end. The examples for this is going to be the biceps brachii. This one we said was what? Calves. So this is the calves, gastrocnemius. And then this one is really the splenius capitis. What's happening in this example of the biceps brachii? Well, we know the biceps brachii. We know that it kind of spans over this antecubital region, and where it's actually going to insert is a radial tuberosity. And so that bicep is pulling from the radial tuberosity. The load is just the weight at the end of your hand, so it's pulling it like this. Bless you.
Sorry.
I'm really fine. That's an example of a third class lever. Question?
On the exam, would it put be specific examples to match?
It will have those specific examples. Okay? And so the way that I generally try to remember it is that this is a seesaw. This is a seesaw. This is a wheelbarrow, right? Because here in a wheelbarrow, you've got, I don't know if I can draw a wheelbarrow. A wheelbarrow is like this, right? And so this would be the fulcrum. Here you've got some load in the middle, and you're applying a force. It's like a wheelbarrow. And then the last one, the example I have is like a canoe moving through water. But just remember biceps brachii. That'll be the easiest one. Makes sense? Okay. And so these are these examples that are right. Another example of second class I should just mention is your quads and the way that it moves the tibia. So that's just another example. Okay. We've talked about this. I won't ask you about intermediate fibers. And I will not ask you about motor recruitment. I will not ask you about motor tone. But I'll just mention that these little muscle spindles, they're also known as Golgi tendon organs, is what maintains muscle tone. We've talked about that. We've talked about this. We talked a lot about this already. I will not ask you about this. I will not ask you about this. I will ask you maybe about where the neuromuscular junction is. And that's just where the neuron touches the muscle. Definitions, sarcoplasmic reticulum. I will ask you about some of that stuff. And then make sure you know this. Make sure, the thing that I messed up this morning, make sure you know that well. So contractile proteins are actin and myosin. Do what I tell you, not myosin. Contractile proteins are actin and myosin. Myosin is a thick filament, actin is a thin filament. What regulates the contraction of muscle at the sarcomere is troponin and tropomyosin. These form a complex that actually covers the actin. That when calcium is released into the cell, it lifts off this troponin and tropomyosin complex and facilitates the binding of actin and myosin. Lastly, there are these structural proteins. The one that's important here is what? Dystrophin. It's associated with what disorder? Muscular dystrophy.
Muscular what?
All right, what should I study? How am I going to study? What's the exam going to look like? The exam is going to be broken up. It's going to be 50 multiple choice questions, 10 true, false, and 10 matching. Those 50 multiple choice questions are really going to be broken up into 7 sections. So you kind of have 7 questions from each of these areas. So there'll be one about general stuff, about muscle structure and contraction, how we classify muscles. So that might ask you about the shape of a muscle there. It might ask you about origin insertion of muscles there. Muscles of facial expression, ones that are involved in chewing. For the ones that are involved in mastication, anyone remember the muscles that elevate the jaw? Temporalis. And what about the ones that open the jaw? Lateral and medial pterygoids. I might ask you a scenario question in where, what if one of these muscles was cut? What if one of these muscles was cut? So let's just take the example of like the temporalis muscle. If the temporalis muscle was cut, what would I not be able to do? I wouldn't be able to close my mouth. If people say that a lot anyway. If it's the opposite, I wouldn't be able to open my mouth. So if I cut the pterygoids, I wouldn't be able to open my mouth like this, which is probably what my wife wants to happen. So you might get some scenario questions like that. You might get some scenario questions from muscles that move the arm. Okay, I'll give you some examples. Okay, if I'm throwing a ball like this, people throw balls like this, right? If I'm throwing like this action here in the lower arm, is that extension or flexion? Extension. So what muscles up here are extending the arm? Triceps, right? The triceps are extending the arm here. If I'm extending my fingers, then that is what muscle? Very good. And so I might ask you, what is the insertion of the muscle that's extending the forearm? So I'm asking the insertion of what muscle? Triceps. So you got tricep long, medial, and long. Lateral. What Michael said. Glad he's so close so he can hear every mistake. Tricep, medial, lateral, and long. So where is the triceps inserting?
Your olecranon?
The olecranon. So the triceps inserts into the olecranon. And so you see how this is working? If I'm kicking a ball, what is the muscle that's extending the lower leg? The quadriceps. The quadriceps. If I'm pointing my toes, let's say I'm flexing my toes, is that dorsoflexion or plantar flexion? Dorsoflexion. Plantar flexion is tiptoes, right? If I'm pointing my toes up, that is dorsoflexion. So the quads are involved in, you can take the whole card. I'll just wait. No.
Ivan Jr.
Oh, Ivan Jr. All recorded. Okay, perfect. So if I'm kicking a ball, what muscle am I kicking with? Extended. Quad. So the quadriceps is going to insert it where? Tibial tuberosity. That would be the insertion. This is allowing me to kick, right? If I dorsoflex, point my toes up, what muscles are helping me dorsoflex? Are they muscles in the front of my leg or the back?
The back.
If I'm pointing the toes up, front. If it's my calves, what happens when I contract my calves?
You do the back.
Plantar flexion. If it's the muscles in the front of the foot, then that is dorsoflexion. What's the big muscle on the tibia? So that is involved in dorsoflexion. See how this is working? So you'll get some examples like that. If I'm trying to shake your hand, I have to extend my fingers. What muscle is that going to be?
Extensor digitorum.
Extensor digitorum. Okay, so you get some of these.
It's okay, it'll be multiple choice. You can really cross some shit
We
off.
already said no to that. And then for this, make sure you kind of understand just the basics of this cycle that we talked about today in sliding filament, okay? ATP is needed for the contraction or the relaxation? Relaxation. If you don't have any ATP left there, that is called the rigor state. That's what rigor mortis is. When you don't have enough ATP, so the muscle's going to relax. Okay, all right. So let's talk a little bit about what's important for origin insertion action. Okay, meat and potatoes. So I'm gonna ask you about all these different groups and kind of about origin insertion action. But I'm gonna ask you about common things. Okay. All these muscles are known as what muscles?
Rotator cuff muscle.
Rotator cuff muscles. I just want to review actions of these muscles. Which one does this?
Supraspinatus.
Supraspinatus. Good. What about this?
Infraspinatus.
Infraspinatus.
Subscapularis.
Subscapularis. Cassandra. Subscapularis. What about this?
Infraspinatus.
Infraspinatus and teres minor. Okay. Good. So we know those actions. All of them, their insertions are going to be the greater turbical, greater turbical, except for which one?
Subscapularis.
The odd one out. Subscapularis. If you remember
It's
that,
the
easy.
loner.
Where is its origin? Well, just the fossa that it belongs to, right?
Mm-hmm.
Done. Rotator cuffs, easy. Rotator cuffs. Okay. What about this? These are the facial muscles, right? And so the questions you'll get will be exactly like the ones you got from the quiz.
Yeah.
So make sure you look at the quiz and see which ones you missed. What is highlighted here?
Skin at corner of mouth.
That is a common insertion or origin?
Insertion.
Insertion. So depressor anguli. Oris, orbicularis oris, the rhizoris, zygomatic, nature, all of those common insertion skin at the corner of the mouth. Now for these other ones, they're different. And so the ones that are different that I'll just talk about briefly, the frontalis and the corrugator supercilli are going to be skin in the corner of the eyebrow, pretty much, right?
Yeah.
The frontalis, the origin is going to be this thing on top of your head. What's that?
Glea
Glea aponeurotica. Glea aponeurotica. Good.
What am I using?
If you might get a question about Botox. Okay. What muscle would I inject Botox to make?
Corrugator supercilli.
Frontalis or the
Corrugator supercilli.
corrugator supercilli. Corrugator supercilli. Those are the two. Anything else I'm going to ask you about? Those are kind of the major key concepts for this. Okay? I'm not going to ask you anything too deep. Oh, maybe I'll ask you this. What's opening my eyes? Eyelids.
The way he did that. He's like,
This is how you feel right now. Okay, so again, scenario questions about this. Scenario questions. If I cut the lateral pterygoids, will I get the guy on the left or the guy on the right?
the guy on the one that going like this. The one on the left. The one that's holding his forehead.
Okay, so lateral pterygoid is involved in what? Elevation or depression of the jaw?
Depression.
Depression of the jaw. If I cut it, that means you can't depress the jaw, which means you can't open your mouth.
But his is
your
open
mouth.
too.
If I were to cut the masseter, then I'd be Larry David here.
Or am I tripping?
My mouth is open. Making sense?
Just better make sure that his mouth is open.
All right, so then muscles of the upper arm. All of these are basically flexors, and there's one extensor here. Brachialis, brachioradialis, biceps brachii, pronator quadratus. They're basically involved in some form of flexion. Flexion of the forearm, with the exception of the pronator quadratus, which is pronation. Okay. The tough part about this is kind of origin insertion. The two muscles that are important here are biceps and triceps. Triceps, super easy insertion. We just said that's the olecranon, right?
Mm-hmm.
What about the origin of the triceps? Where is it originating? Yeah, all these places. So inferior glenoid cavity and medial lateral head of the humerus. I would just say head of the humerus and inferior glenoid cavity. For the biceps brachii, it's not the inferior glenoid cavity, it's the superior glenoid cavity. And the other short head is going to the coracoid process. Where is it inserting? How is it pulling the arm like this for flexion? Well, it is attached to the radial tuberosity, and that's what it's pulling. So those are kind of the key ones for that. Okay. All right. Now this is difficult. Difficult. So what about extensors? The first thing, and this is the way to think about it. The first thing is, are the extensors in the anterior compartment or posterior?
Posterior.
Posterior compartment. Posterior compartment. And so, if you look at it, what is the origin of all of these? Of all of the flexors first? Medial epicondyle. Medial epicondyle. When you flex, medial epicondyle. When you extend, lateral epicondyle. Done. Origin's done for flexors, extensors. What's tough is the insertion. Now, if I look at the insertion here, if I say, what is the insertion of the extensor carpi radialis longus, and I give you a big list, it's the second. So that is the ulnar side or the radial side? Radial side. If it's the ulnar side, it's going to be the fifth. Let's look down here. What about flexor carpi ulnar? Fifth. Okay. Flexor carpi radialis, it's second and also third, so it's a little bit different. So just think, so that's a good way to be able to eliminate things in multiple choice, right? And so if it's second, it's going to be radial. If it's fifth, it's going to be ulnar. So keep that in mind, that'll help you with it. All of these except one is going to flex, or most of these are going to be involved in the movement of the wrist, right? They're going to be a weak flexor or strong flexor or extensor of the wrist. The only ones that move the fingers here are which two? Good. So the extensor digitorum and the flexor. That's yeah. Flexor digitorum superficialis. So if you keep that straight, you're good. You do not need to know the profundus. Which one of these muscles inserts into the flexor retinaculum and is missing in about 20% of the population? Palmaris longus. You will see that question. We all know that. Okay. You'll get some questions on compression of the stomach or lateral movement. Of all of these muscles, which two are primarily involved in the compression of the stomach? Transverse abdominis and rectus abdominis. The internal and external obliques is partially involved in compression, but we really think about those involved in rotational movement. Rotational movement. So make sure you keep that clear. The other thing that's difficult for these is origin insertion. And I'll tell you that, so the reason I'm highlighting these two here is because these two share a common origin. So you'll get a question about that. So which two share that common origin? Transverse abdominis and internal oblique. So they both are originating from the thoracolumbar fascia. The rectus and the external are different. And so three of these actually insert into the linea alba as well. So, but the key things to remember for this is like, the obliques are really the only ones involved in rotation, okay? And the internal and transverse are the only one originating from the thoracolumbar fascia. Okay. And then the rest of all of this, right? Okay, so the legs. How are you going to keep all of this straight? Well, again, what I'm going to ask you is common things. Hamstrings all have a common origin or insertion? Not insertion, origin. Hamstrings are all going to originate from the ischial tuberosity. Quads are all going to insert into the tibial tuberosity. Hamstrings, ischial tuberosity. Quads, tibial tuberosity. Hamstrings, ischial tuberosity. Quads, tibial tuberosity. So if you keep that, so I'll ask you that. And then let's talk about the bus for a second. So if we think about these maximus, medius, and minimus, in terms of insertion, two of them share this common insertion. That's the greater trochanter. The maximus is different. Okay. The maximus inserts right into the IT gap. So that's the different one in that group. And then I guess the last major kind of landmark that plays a role in origin insertion is the linea aspera. It is the insertion for the adductors, longus and magnus, but it is the origin for the vastus lateralis and medialis. Vastus lateralis and medialis. So as you're, going crazy, trying to study all of these, think about those common things. So it's just what I'm showing here again. Linea aspera, right? For these guys, all of these are going to be tibial tuberosity. In terms of insertion, here's the hamstrings. Ischial tuberosity for all these. And then they're going to go to the tibia. Okay, we're way over here. Okay, so that was a fast, dirty review